Hello everyone, welcome back to my channel. Today I'm going to walk you through a complete DevOps Capstone project based upon a real world scenario, a company called KMIT Solutions Services that is running a banking application. We will see how this company transformed its traditional manual software process into fully automated DevOps CI/CD pipeline using tools like Git, Jenkins, Docker, Kubernetes, Ansible, Selenium, Prometheus, Grafana, and so on. So there will be a couple of videos related to that. So you need to stay tuned on this series. And step by step, we will see how we are converting a project into DevOps culture. So um, if I go to the existing project problem statement. So here I'm taking the example of KMIT Solution Services, which is my company. So it's a software company who is developing a Spring Boot Java-based application for one of its clients. The application includes multiple modules, and these modules are internet banking, withdrawal service, deposit service, customer care services. So these modules are part of my application, and we are using a layered approach to develop this application. And these modules are deployed on Tomcat server. It could be single Tomcat server or multiple Tomcat servers where these are deployed. Now, there are some challenges. So the challenges are number one, manual builds. What does it mean? For example, if a source code is ready for the production or some environment, then we need to build the code. What is the meaning of build the code? Build the code means you need to create a executable file. So to create the executable file, we need to compile our code. We need to create a package for our code. So there, build comes into the picture. So there were manual builds and deployment. So developers manually build the jar file. So I'm taking the example of Spring Boot application, which is a Java-based application, and it converts into the executable by using jar or var file. Okay. So if you are using some other programming languages for your project, there will be their own executable files. Okay. But if you are going to follow this particular project, so I'm going to use Java source code, okay, which is a Spring Boot application. Now, deployment to the Tomcat servers are done manually, causing inconsistencies. So whenever you are pushing the code to the Tomcat server, and if there is any problem during the deployment, then rollback or how to revert back the changes, then it is a challenge. Next one is the frequent code changes and developer coordination. So what happens that when multiple developers, they are committing their code. So say an example, there is a source code, and this source code is developed by multiple developers, say dev 1 and dev 2, or maybe there are multiple developers. Now they are developing the code on their machines. At the end, that code will be integrated into final repository. So during this traditional approach, they face this problem that whenever they are committing their code on their machine and they want to integrate onto the main repository, so they were facing the challenge during the merging to the final branch because it was very complex and it was error prone. Next is that testing. So what is testing? There are two types of testing. One is called the unit testing. One is called the integration testing. So here I'm talking about the integration testing. So in the integration testing, basically what happens that If there is a developer who is writing the code and he give it to the testing team for testing the application. Now, when the testing is happening, because it's a manual or automate testing also, so they are doing it testing on their test environment, and after maybe some amount of time, they are reaching to the developer by saying that there are some errors into the code, so you need to fix that. So while it was testing, developer cannot think about the enhancement of the application because he does not know at that time whether my application is working fine in the test environment or not. So integration testing is manual and time consuming. Developers lose the productivity waiting for the test result. So that was the another challenge. Next one is the dependency and the environment drift. So it happens multiple times to the company that something is working in test environment or staging environment or UAT environment, but it is not working in the production environment. So it is working here, but it is not working in the production environment. There could be n number of reasons because here the infrastructure is different. Here infrastructure is different. Maybe you are using the same operating system, same set of um, hardware configuration, but there could be some other application dependency. For example, in the application, there is a hard-coded path, but that path exists in the test environment, but it does not exist on the production. Maybe you are using a older version of Java in production. Here you are using Java 8, and here you are using Java 21. Your application is built on Java 21 and it is working fine on the test environment or dev environment, but it does not work in the production. So that was another problem for the existing application. So configuration mismatches cause the failure during the production deployment. Another challenge was infrastructure and configuration management. Now, for example, in the production, you are having one implementation plan and you are asking operation team to install those software and they are installing manually. Not only installing the software, maybe you need to create the users, you need to give some permission, and everything is the part of your implementation plan. But if something goes wrong, then probably your application will not work. So that is why we need something, an automation system here. So infrastructure as a core tools in DevOps, which is Ansible, Puppet, Terraform, etc. So those are helpful for managing infrastructure as a code. But such kind of thing was not there in the existing environment. So that was the another challenge. Next one is the lack of monitoring. So there were a lot of servers and applications which are monitored manually or with some tools which are not productive. So the issues are not discovered um, proactively. So, so that was the another problem in the existing system. So because of all these challenges, company decided let's move it into the DevOps environment because DevOps is an automation process. So I hope in this lecture you understand the purpose of existing application, the problem which exists in the existing application, and why they are trying to move into the DevOps. So DevOps is the solution for that because here whatever the challenges we have discussed, so we can convert it into an automation process. So let us move to the next lecture, and there we will see how DevOps will helpful for uh, solve these challenges. Thank you very much for watching. See you in the next lecture.